Hello everyone. Today I'm going to walk you through a data cleaning project where we transform messy student data into a clean analysis-ready data set. We'll be working with Python, Pandas, and handling real-world data quality issues that you'll encounter in any data science project. Our dataset contains student information including their ID, age, gender, class, and scores across 6 subjects: math, English, computer, sport, attendance, and art. Import Pandas, our main tool for data manipulation. Let's load our CSV file and take a first look at the data. Right away, we can see several issues: missing values shown as NaN, empty columns for total score, average score, and grade that we need to calculate, and the age column stored as an object instead of integer. Problem 1. Cleaning the age column. Our first challenge is the age column. It contains the string 16 instead of the number 16 and has some missing values. We'll replace the 16 with 16, 16 foot, then fill any remaining null values with the median age. This approach preserves the distribution of ages in our data set. Problem 2. Handling missing gender values. Next up is the gender column. We have some null values here. Following the project requirements, we'll fill these missing values with male as a default value. Problem 3. Cleaning the class column. The class column also has missing values. We'll fill these with as our default class assignment. Problem 4. Imputing subject scores. Now for the biggest cleaning task, handling missing values across all 6 subject score columns. For each subject, we calculate the median score and use it to fill missing values. This is better than using the mean because medians are less sensitive to outliers. We do this systematically for math, English, computer, sport, attendance, and art scores. Problem 5. Data type conversion. Looking at our data types, we see age is stored as an object when it should be an integer. We'll convert age to integer and prepare grade as a string since it will hold letter grades. Problem 6. Standardizing decimal values. To make our scores more readable and consistent, we'll round all score values to whole numbers. This removes unnecessary decimal precision and makes the data cleaner. Problem 7. Removing duplicates. Data duplication is a common issue. We'll check for duplicate rows and remove them to ensure each student appears only once in our data set. Problem 8. Calculating metrics. Now we can calculate our derived metrics. Total score is the sum of all 6 subject scores. Average score is the total divided by 6. These calculations use lambda functions applied across each row of the data frame. Problem 9. Assigning letter grades. Finally, we assign letter grades based on the average scores. We start with D as the default, then upgrade to C for averages 65 and above, B for 75 and above, and A for 85 and above. This creates a traditional grading scale. And there we have it. We've transformed a messy data set with missing values, incorrect data types, and incomplete information into a clean, analysis-ready data set with calculated metrics and letter grades. The key takeaways are: always explore your data first, handle missing values thoughtfully using appropriate methods like median imputation, ensure data types are correct, remove duplicates, and derive meaningful metrics from your clean data. Thanks for watching and happy data cleaning. Please like and subscribe for more.